No, but I was looking for their proposal. Do you know where it is?
No, I was hoping that was it. But we
No.
are live talking about Kubewarden today. Welcome back, everybody, to another episode. Carlos is back, and we're doing Kubewarden today. I'm going to go ahead and cut off into the background. Did you find it? Unless I'm getting all of
No,
you.
no,
Oh,
but I'll do the as we're okay. No
yeah,
problem. I will look in the TLC. They did a recent review, and the reviews go here, right,
yeah,
in this repo. The
yep,
sandbox applications is in the other repo.
yeah.
Okay,
For
cool.
those of you listening, each of these CNCF projects has a process in which they enter the CNCF and reports on their project health, how they're organized, the governance, all of that kind of stuff. So a good
Um,
trick is to go read those when you're learning about the project, to
yep,
give you a little bit of the context on how they ended up in the CNCF.
yep. That's just, or maybe it's just Carlos that likes to do that.
I do that too. Yeah, yeah. I recommend to people when they onboard into cloud native that they need to do
Yeah, this is
the trick
the. I
one.
was looking for
Yeah,
the stats and more information, but yeah, this is good enough. Other projects have that. So let's kick it off. I think we
let's
have
go. I
people
am
on
out of here. I'll be
online.
in the background. Good luck.
Yeah, looking to the side because we have the chat, but yeah, I think we are live. This is the crash loop back off from the CNCF where we have ambassadors come in. Like myself, I'm a CNCF ambassador. My name is Carlos Santana, working at AWS as a specialist solutions architect on EKS, all things EKS, and then the CNCF. Basically, this episode, if you haven't seen it before, we do it every Thursday. Ambassador comes in, and then it's given a CNCF project that they don't know anything about. So that will be happening today. I was assigned Kubewarden, and I had like 2 or 3 days to look into it. And then because we want to do it live, we want to do it together. So if you're in the live stream, either on YouTube, LinkedIn, and the different platforms, please put something in the chat. And also, as you have questions or suggestions, you can put it there also. So work on everyone. If you're watching the recording, feel free to go to CNCF. Actually, the Kubewarden project is on the Kubernetes Slack. So if you want to have more questions there. I have a hack MD here. This is new that for today. And these live streams go very fast. It depends if there's we crash and burn as we do this live. So I have this. This is an experiment I'm doing to see if it will work. So HackMD is a little utility to do markdown editing. So just at the end, if people want to put some links as we talk about or suggestions or cool stuff about Kubewarden, you can add it here. So it's like a community thing. So I don't know if I can put it in the chat. I'll give it to Jorge to see if Jorge can put it into the public chat. If not, the other way would be the Kubernetes Slack. There's Kubewarden here. They're in the Kubernetes Slack. And I can put a message here. Kubewarden, and here is the HackMD for today. Okay, so let's kick it off. What is Kubewarden? So first thing that I do is a CNCF project or not. So I go to CNCF landscape just quickly. If you want to do this for any project in the CNCF, these are all the projects in the CNCF, but none of them are CNCF projects. Is this landscape? That's a very misconception. People go to the CNCF landscape, they see so many projects or products or things available here. None of them are CNCF projects. There's less than you see here. Group of sandbox incubating and then graduating. That's what they go through get graduation. Actually, that was a blog post. I don't know if Jorge wants to put it. Blog post recently that talked about the how many projects we had for the past years, and then also talking about archiving projects. So some projects they need to be archived. Last year there was a wave of projects that got archived. So it looks like the TOC did some cleaning in the house. So let's go to Kubewarden. Let me make this so it looks better. So Kubewarden is a policy engine powered by WebAssembly policies. Its policies can be written in Cell, Rego, OPA, Gatekeeper, ROS, Go, YAML, um, uh, / TypeScript, WebAssembly, things that can be run in a web assembling runtime. And the idea is that you use code or expression, because Cell is kind of more of an expression than a language, to write those policies. And the intention is has kube in the name, so it's for Kubernetes to give you policy. So it goes along. It's similar to other projects like Gatekeeper and Kernel. And I will talk about like what will be the difference between Kubewarden and Gatekeeper and Kernel. It's in Sandbox since 2022. In terms of stats, they have this repo is not the main repo. That's the first thing I noticed. They have many repos, about I think it was 98 repos, but the main is like two policy server and Kubewarden controller. Other ones are like majority of all of these repos are policies, and you will know. I'll tell you in a second why, because policies is their code, right? It's a JavaScript project, a Rust project, or a Go project that you compile into WebAssembly, and that becomes a single policy, and then they're stored in an OCI registry. So that's the overview of like writing WebAssembly. You're not write WebAssembly. WebAssembly is the runtime. You write in one of the languages that gets compiled or transpiled into WebAssembly, and that becomes your policy at runtime, like the thing, the code that validates if we're going to admit a request into Kubernetes, because it could be a create, could be update, could be delete, and then you're going to allow it or not allow it, or even you can mutate a resource coming in. Like if you're going to create a resource, you can make a mutation policy. So with that, the website is the best place to look at Kubewarden, and you can get there from here. So I'm just showing. You can Google also and get there, but I think using the CNCF landscape and showing people how to use the CNCF landscape, I think it goes very far, and like people are learning about the CNCF and other aspects of the CNCF. Um, I was going to look at the CNCF Sandbox. So the project, I think they did a 23 annual review. Let's go and make it. There's some formatting stuff here. Let me see if we can make it. See the source code. That's worse. We'll do it like this. The dev stats page is here. Oh, that's another thing. If you have not seen it, CNCF has some Grafana dashboard that shows the activity of projects. So you can see things like there at the bottom. Like this is a little bit confusing to navigate this, but you can. We're already in the Kubewarden DevStat dashboard, and then there's their dashboards. There is already filtered, so you can go and see like company tables, right? Who's contributing to this project? So this project was donated by SUSE, and I was created in SUSE. So that's from the, let's say, the last 2 years. From the last 2 years, you can see 20,000 contributions. These are like PRs, issues, things like that. 27,000 are from SUSE. So this is a SUSE project. Don't know if there's others companies doing maybe small contributions here. And it says independent CloudBees, which are the folks from Jenkins, Multius, L2M, and Q. and those things. But it looks like it's a SUSE project, and I believe I think I was looking online. It's from the SUSE/Rancher family, and they have enterprise support for it. So that's a good thing. If there's any maintainers in the chat and you want to clarify or add, go ahead. If we have folks in the chat, and you can chat in LinkedIn or you can chat in YouTube. So yeah, if you are in the HackMD, basically these are the things I covered. Like, it's a sandbox project since 2022. It's basically it's a dynamic admission controller in Kubernetes that validates incoming requests, validates or mutates. I should put that there, right? I guess web assembling policies, and policies can be developed in any programming language. That's the gist of it. So if you're using Gatekeeper or Kubernetes, right? In Gatekeeper you use Rego, in Kubernetes you use YAML or Cell. Then with Kubewarden, if you want to use other things than YAML and Cell on these things, so for example, you want to write them in Go because you have a library, you're starting to do them in Go, or Rust. Rust looks like it's very popular in terms of the policies available, and Rust is a very good language for compiling into WebAssembly. So it's mentioned a lot in the project. Let's look at the website, and let's go through the getting started. I did this last night, so it should work today. This is the website, and then the docs. If somebody comes in here, also take into account that when I say you'll be writing policies, the project already has very common policies, and they're available at Artifact Hub. So we'll see that in a second. And people share the policies, and you can look online on GitHub, for example, through a filter, and find all the projects that mention Kubernetes policies, and people share them. And then you can use that source code to get a starting point, or build the images, the policies, and use them in your environment. This is the getting started. Yeah, they have a quick start, and then they have a Slack channel in the Kubernetes Slack, like I mentioned. Oh, I went in there. I was asking questions this week, and they're very, very responsive. So that's a good thing. That's a good. And the other thing I was looking at, it looks like they have Slack. They have a blog post. Let me see the blog post. I think the blog post will have they put the releases. So that's another thing that I noticed. Like February 26th, that was yesterday. They did a 1.22 release with some features added, and also like some breaking changes. But they also take into account um, um, patch releases, like for securities, or like code that they depend on, and they have to like patch dependencies. They keep that on today. So if you see a project, open source project, like doing this type of releases, and then, like the releases are recent, that's an indication that the maintainers are keeping it up to date. And they have a nice, I was reading, this is a nice summary for 2024. The maintainers did an update of what are the things that they did in 2024, and it looks like adding Cell was some of the new things that they added. And this goes along with the upstream Kubernetes project that they added Cell support for validation and mission policies, which is a new feature that went GA in 131, I think. But we can check it out. So that was one new thing that they added: performance and reliability, scalability, and community outreach. But I think that the Cell one, it was and then a summary of like the things they have done. So this is a good example for other projects in CNCF to do, to highlight the enhancements. And usually it's not features, or like things like this, right? 55% performance boost. It could be non-functional enhancements. It could be security related, it could be performance related, and do a nice summary at the end of the year. Actually, is a very good thing for newcomers coming in to say, is this project really active? Are they keeping up to date? What are they working on? They're adding features, are they listening to folks? So that's something to for other CNCF projects to emulate. I think we have some folks. Oh, and we have, I think, what some of the two maintainers. I think Victor and Flavio. Hi, Victor and Flavio. I don't know if Jorge can put those two messages in the stream. So those are the maintainers. So you have like the people that actually know this stuff. I just know it for, they know it for 2 years. I know it for 2 days. So I'm trying to just highlight the things that are good in here and things for improvement. I've been giving them feedback based on my experience working with open source projects. I think Jorge is oh, he's coming back. I'll tell him again. But yeah, they're in the chat. I think they're in YouTube, so people in YouTube can say hi to Flavio and Victor. And it looks like Jose Guillermo. I crossed the name. Gil Herme. But it's Jose. Is also in the chat. There you go. My admin. Listen to me. So they're their stamp of presence, maintainers like going to live streams and answering questions. That's a proof that this happened for real in the CNCF. So let's get started. Like that's for like the folks that like, what is Kubernetes? Like now you know like what is the policy. Let's go down for the folks that actually know Kubernetes, and like let's move to the next level of complexity here or depth. So let's go to the website. I'll go to the docs and I will try to install this and then follow their tutorials, and then they can get feedback of like, yeah, we should improve it, or we should change this, we should remove that. So I think I went over this, like what is Kubewarden? It's a policy engine. Basically like allows you to do the next level of functionality beyond what Kubernetes offers as a base, which are now is validation mission policies. But for the longest time, they offer webhooks, right? Where you write in Kubernetes a validation webhook or a mutation webhook. And basically that in Kubernetes that's basically the configuration saying like, hey, filter based on these resources and send a web request to that server. And then Bob's your uncle, like whatever that server decides to reply with is what the policy is. And that's how it works in Gatekeeper OPA kernel, right? The request gets sent and processed by the engine in Gatekeeper or kernel, and then responds back to the Kube API server saying A or nay for validation, or um, here's a mutation, a patch that I want to do to that resource. Kubewarden, same concept of implementing the API that Kubernetes provides. Is it gets the request and it will send it to that server, and that server happens to be a Kubewarden server, and it's called the policy server. And then that policy server basically will say A or nay, or mutated based on whatever policy the admin have configured in Kubewarden, and those policies are running in a server in WebAssembly runtime. And I believe and then the maintainers can correct me, every individual policy becomes an endpoint, and then that endpoint runs on their own WebAssembly sandbox. That means that if there's code running in one sandbox, it cannot like invoke maybe another policy from the same server. So it's their sandbox. There's no memory shared. There's no communication between like two policies that are like loaded in basically memory, right, to be executed. It's code that is living in the stack to be executed. They can just communicate with the host of WebAssembly. And if you don't know WebAssembly, there's a bunch of talks in the CNCF. The CNCF for the last few years have becoming very popular in terms of WebAssembly projects. Strong support for verifying those policies that are signed. For example, not just the images that are running in a pod, but since the WebAssembly is packaged as an OCI image, it can be signed, right? And you can check that is the intended supply chain, right? Security. Make sure that that's the right bytecode or right code that you intended is that image of that code is signed. What else is here? New to Kubewarden, start with architecture and this. I think let's go. Let's do the get started. So I'll do this exercise on a. It says to this part. I'm confused. It says that you have to authenticate. It says can retrieve Kubewarden policy from GitHub Container Registry. You need to authenticate to use the repository with Kubewarden CLI. I think this is maybe needed for the Kubewarden CLI to push to your GitHub if you're going to use the GitHub registry. I didn't do this and stuff worked, so I'm going to skip it for now. And the maintainers can correct me in the and then Flavio, you can put the message from Flavio. Flavio is saying, yes, that's correct. Everything is isolated. So Flavio is giving me a thumbs up. Like, Carlos, you read this stuff last night. So let me bring VS Code and let's do some things here. I have a cluster. I already have it running because I was playing with it last night. I have like audits and stuff. So if we want to start from scratch, we can just delete this kind cluster and start it again. Kind get clusters. Did I delete it? No, it's there. This autocomplete didn't work. So that's deleting the a cluster. I don't have a cluster. Oh my God, I lost my Kubernetes cluster. So let's create one just for. It's always good to show people like how to get started from scratch. Some people are like new to Kubernetes, so kind is a little utility that uses Docker to create a Kubernetes cluster in your computer. A lot of like developers that are like admins and like need to like test controllers or writing controllers use it. So with that, I think I have some notes here, and they're also available in the HackMD. So I just copy it here. We need to install three things. It says to install the CRDs, and that's a separate chart. So let's do that first. So, and it will be in the, well, I don't need a namespace unless this thing is going to create. Anyway, little trick that I like to do is I do Helm template, and I get all the YAML that is going to create. And basically, these are CRDs. But I don't know why I need to specify the namespace. I guess, yeah, I know. Helm is something that installs in a namespace. It creates a secret with the values. So that's the management thing. But basically, these are CRDs. So let's do it. It's not nothing to I'm not teaching Kubernetes today. So that created CRDs, right? One thing that I would love for Kubernetes for him to say is like what resources got created. But yeah, the node is available here. So if you do get, Jorge, tell me if this text looks okay here at the bottom, or maybe people in the chat. If I do get, no, that's not a one. Okay, get CRDs. This autocomplete is going me crazy. So these are the CRDs that got created. So you have a mission policies, which are a mission policy that you write scope to a namespace. You can put them in a group. And then you have the same thing, but it's cluster-wide policies. Like, for example, things that you want to validate namespaces creation, right? Or like those type of things, or something that you want to say, I want this to be applied. Doesn't matter the namespace. You can group them, cluster policy report, and policy reports. That's basically objects that get created by something called the audit scanner. So the audit scanner will create those reports, and then there's a policy server UI that you can use it to watch them. So for that, that's why I have this one here saying audit scanner policy report equals true. I think the audit scanner is installed by default. I think this one adds the policy reporter UI that you may not want to install. So I'll do this one, and I should be able to get the policy reporter also. If I go to the website, following the instructions here, installing the CRDs, the controller. So the controller, we'll look into the architecture in a second, after we see the things are getting installed. Okay, I see that text looks good. Oh, Fabricio, also a maintainer, is here. Hi, Fabricio. Welcome. Okay, Fab is saying that the authentication with a container registry is for pulling and pushing, if they're private registries. So, for example, and as for the KWCLT control, like the Kubewarden CLI, to pull and push to a private repository that you have, and then you have to like give it the Docker config in the Docker config format. So we'll read your Docker config, the CLI. In the cluster, since policy server is going to start pulling down images, those images are the policies you need to authenticate, and you have to configure, if it's a private container registry, you have to configure the username and password, or username and token. And that this is something that I discussed in the Slack. I use AWS ECR, and that token expires every 12 hours or 8 hours. And I was discussing in Slack, I think there's an issue to improve around that, on how to support rotating, like for registry that rotate that policy, that token. But yeah, it will pull down those things. So what we got here? We get pods -a. Okay, get pods -a. And we have the Kubewarden pods, and I have the controller running, and I have the policy report running. I don't see the scanner. I thought there was a scanner. So maybe the scanner gets created when the policy server object is created. So, and then you can create a CR for the policy server, because you can have multiple policy servers in the system. One is the default one, easy to get started. Maybe that's the only one that you need. But if you're testing, or maybe you have a multi-tenancy cluster, maybe you want to have like a shard of policy servers handling different tenants, for example. So this third Helm chart is like a helper thing to help you with the CRs, the CRs of the CRDs that we already installed, and it's one that this kube controller would take, and then create the policy server, which becomes a deployment and stuff. So let's do this. So let's inspect on what this thing does, so people can see. I think this might be interesting. So I'll do a Helm template, and then I'll put it into policy server.yaml. I would, as inspected here, policy server.yaml. It said the scanner is a cron job by default. It runs every 60 minutes. I see. So let's see. That's good then. Cron jobs -a. Okay. So here's the scanner. I saw a pod running when I did it yesterday. So yeah. So this thing, I think this thing gets installed by default. What I did was this policy reporter and the policy reporter UI. So this policy reporter will look for policy reports, CRs, and then the UI is a web app that you can see those reports consolidated into a view. So we'll do that. Oh, I'm in 12:30. I'm doing better than last time. So yeah, this thing will run. I'll explain a little bit more on how this runs every 60 minutes. Okay, but yeah, there's something that we can trigger the job to run. So what was I going to do? Oh, policy server. So the policies, every this is control blade base, right? This is Kubernetes. Everything is CRD. Everything is a CR. So if we want an instance, so basically this policy server will create a service account. this service account is going to be in the namespace Kubewarden. It's called policy server. And the reason that I read that is because this service account will be used. We're going to give it permissions, and the permissions that we're going to give it is this cluster role. It's not namespace; it's cluster role. So across the whole cluster, it's going to be able to list, watch, basically get, list, and watch. Basically, read any namespace, any pod, and any service, and also be able to get and list and watch any ingress. And you will say, why does this pod needs access to my Kubernetes cluster? If the only thing that it's going to do is take a web request to evaluate it and reply with yes or no, is because this policy server actually give host capability, like a policy. If you write a policy, you'll be able to query the live and the list of pods or namespaces or ingresses, because maybe that's a logic that you would use in your policy to deny or allow it. For example, if let me think out loud. If someone is going to create an ingress, for example, and he puts host carlos.com, not that I'm that famous, and the policy says, well, there should be one ingress in the cluster that has the host name carlos.com, and then you're going to create a second one that is different from the one that is there, then the policy that is in WebAssembly running will talk to the host saying, hey, please give me the list of ingresses so I can iterate over them, find if there's carlos.com, and if there's no carlos.com with the host, I'm going to allow it. But if there's one with that, I don't want like two ingresses pointing with the same host name. That could be like an error that somebody's doing. So that's why this service account will be used by the host to access that information. So only these things are available today. I don't know if the policy server is able to provide more Kubernetes resources, and then we need to give it access, or it's just this is the fixed list. The maintainers can answer in the live stream. And then you do the cluster role binding. And then if you're like lost on why I'm doing this, this is something that Kubernetes administrators do daily, right? When they're evaluating a new software that they're going to deploy to their clusters, they just don't just grab a Helm chart or a new version of Helm chart and just like blast it to the clusters in production. They usually start with Sandbox, and before Sandbox, they start inspecting what is this Helm like YAML or the template actually doing. And sometimes for error or malicious things, it can add cluster roles and permission that it shouldn't, or it has more permission that it shouldn't. So understanding like what is the installation process. I didn't explain the other ones, but this one I think it was more enough to explain it. Basically, if you want to be Kubernetes administrator and you start in your Kubernetes journey, this is where you're going to land, understanding the systems and the configuration of these systems. I think that was a rant. Sorry. So yeah, then you do a cluster role binding saying this service account will have that access. It'll be able to watch the context, and it's called the context, like host capabilities. I want some context of like, I want to see the pods or the namespaces. Is it deployment also, or just namespaces? Pods, services, and namespaces. Yeah, that's it. Let me see if the maintainers answered that question. But yeah, that was an open question. And then this is the CR for a policy server saying, I want a policy server. In here, you can put things like pod spec. So like environment variables, anti-affinity, node affinity. Like basically the controller will create a deployment for you on a service, or the service account is created. I think the deployment and a service. I think that's only two things that it creates, and a config map, because the config map is going to come in play in a second, which the config map will have the configuration for this policy server when it starts. And then you want one replica, you want redundancy, you can put two. But I think one is enough. And then this is the 122. So we're using the release from yesterday, 126. Yes. So this is fresh. So let's install it. Let's install it here. And put in the chat if you are following along. So let's do this. Install this guy. And then if I do get policy server, right? Dash A, because I'm lazy. See, there's that's the CR, the kube controller, the Kubewarden controller. Now is creating the, if I do get O-N Kubewarden, then it created the policy server default. So 23 seconds, there's a deployment, there's a service, and this service is important because that's the service and the endpoint that the Kube API service is going to send the webhooks and the mutation webhooks. So the Kubewarden is out of the picture. Like it goes Kube API server and then directly to the policy server for the policy to be evaluated. And then this is the pod that is running. What else do I have here? And then it creates, I think, a config map. Let's do like config map -n Kubewarden. Just to explain something that I learned this today. So there's a policy server default, and then this policy server default config map is mounted in the policy server deployment. I'm not going to show it, but I'm going to show the content of this, and it has two files basically. You're going to, so this is the configuration for the policy server. So it has policies and sources. So you can see policies is empty. So the way it works, when you install a CR of a policy, the Kubewarden controller will see that policy CR and it will reconcile. And what reconcile means is two things. It will update this config map policies.yaml saying this is a image. So we'll add the image that the policy server needs to pull down, basically the WebAssembly code. And if you have 10 policies, you will see like 10 registers here. Like these are the things that you need to load into your WebAssembly program, right? In the server as sandboxes. If you remove a policy, then it comes in here and remove it. And what happens is the policy server would restart. Well, no, it will not restart. This gets updated. The Kubewarden controller would restart the deployment, wait until it's ready through a health check, and when it's ready, it will create the mutation and webhook and hook them or wire them to start sending those policy requests for the new policy to the web server. And this is something that is getting improved. There's a proposal in the repo to improve this, to make it like hot reload instead of like having a pod being restarted, because it could be that well, not restarted, like a new one gets added. It's like blue green, right? The new one gets added, so you don't have any downtime. The previous pod is handling those requests, and then it transitions to the new one, and the services get routed to the new one. I hope I explained that correctly. And there's a question. One can configure policy servers with your own service account with different permissions. So that's the question. So Victor answered the question there. So let's go to the website. It says to create it. And I just explained this, right? Instead of like showing you here, this is the policy server. In our example, it has one replica. This one has 2 replicas. And I had a power failure, but I think it was still alive. I have a battery in my lap. I have batteries everywhere in the house. And then let's create our first policy. Oh, here's an example of a cluster admission policy. I think this is is this a policy that is cluster admission policy? Resources the core of the Kubernetes stack. Is this one already installed? I think this is an example. So an example of what is a cluster admission policy, which is the most common one, because you want to start with policies that apply to everyone. So you'll be creating a cluster admission policy. And then this one is an example of a PSP capability. So if you remember, PSP in Kubernetes got removed in Kubernetes 1.25, and a lot of people were looking for alternatives like the PSA, pod security admission. Pod security admission gives you some Some similar capabilities as PSP, but not all of them, because PSP were able to mutate. So PSA is not. So that's why people use things like mutation in Open Gatekeeper and Kyverno, and then in Kubewarden also does Kyverno, right? So it explains like what are the different fields that you need to put here. So let's look at this policy, like just as an example. So this is the module. Well, this is the policy server. As I mentioned, you can have different policy servers in the cluster. So when you create, well, the examples will always use the default one, but it could be a tenant. The module is the WebAssembly module that is already a container image with the WebAssembly code in there. And that code got converted into WebAssembly, and it came from Go, it came from Cell. Well, not Cell. Cell is it's actually the WebAssembly runtime. But it could be Go or Rust that you compile into this. And then these rules is similar as the ones in Kubernetes, filters that get translated one-to-one to the mutation validation webhook. Mutating is just indicating like I'm going to be mutating or not, or handling mutations or not. So the controller knows to create a mutation webhook. Settings is I would say settings like the configuration or the information that is host in the policy. I guess configure. I would say this is configuration, and the policy itself is the logic in the WebAssembly code that has two functions: validate settings and then validate the actual request. So that's the schema. If you want to do something specific to a namespace, then you will create an admission policy, and then that would filter the webhooks to a certain namespace, for example. Let's do the first example, which is I'm going to create a cluster admission policy. The name will be privileged pods. The policy server is not indicated, so we'll be using the default. It's going to go to, it can go to Docker Hub or a public registry or a private registry. And then I can mention like the private registry that rotated token. I think that's something that the team will look into. This one policy is pod privilege. So it's a container image, right? It's not intended to be running a pod or like to run, but it's a packaging system. The same way today we have Helm packages stored, right, as OCI images, fancy word for Docker image. So the server would download this code and then run it. Like when it starts, it loads this into WebAssembly code with the other ones. And then the rule like explains the filter is not going to mutate. So this policy, what it does is doesn't allow pods with privilege. Like you don't want anyone in the cluster, anyone in the cluster to be running pods with privilege. You put this policy, and then you solve that issue. Take into account that the majority of folks will be using Kubewarden with existing policy, because this is very generic code. There's no reason for you to rewrite this code if it becomes a policy that you can pick up from a library, for example. This is the same concept for the library of OPA or Kyverno. One thing that I would say is if you're in the enterprise, don't take this image as it is. Maybe not, but I would recommend inspect what is the code, who he came from. Maybe download the source code. Maybe put in your CI/CD pipeline and compile the code in a secure build environment, sign it, and then put it in a private registry and use it in enterprise. I think this is how people will use it in the enterprise. Me being the solutions architect, that'll be the recommendation. So let's run it. I think we're going to see like one image. Okay, so we have one here. So if I do cluster admission policies, warden is there. It says it's pending. Check it out. It's pending because the controller is put the information in the config map and restarting. So if I do get pods -n Kubewarden, you can see here this guy is terminating. This one is the active one. And then we can check the config map. And then, like I said, this is the current behavior. There's a proposal to make it hot reload, but that's a minor thing. Okay, get config map -n Kubewarden. give me the policy. And we'll see here that policies.yaml now, instead of being an empty JSON object, it has the information about the policy and the location, right? It has the location of the code that, so policy server restarts and downloads this code, and then run it. And then now, and it becomes active with the endpoint of / the name of the policy, which is, I think it's this guy, / privileged pods. And since it's a cluster scope resource in Kubernetes, not other cluster policies should have that name because it's cluster wide. So let's see if it's active. Yep, it's active. And then there's the observe mode, which is like kind of like the default saying like I'm not going to allow it, and then like you will not be able to create. There's other modes like monitor. Maybe you want to start like putting this in a live cluster today and start monitoring whose policies that are like being like not follow, and then you start like enforcing that, and so you don't break apps start running. Mutating, this will not mutate. This is going to validate. So the thing is, it's going to create a validation, validating webhook, right? So as you can see, 94 seconds ago, the controller created that for this row. We created this. Let's see the YAML. This is a YAML show. I basically created a Kubernetes, a normal Kubernetes mission webhook configuration, telling the API server saying, when you see a request, and here's the client config. So it's going to connect to the service. So this is the policy server service that is running in that pod. It's going to run with this endpoint cluster wide. Oh, so sorry, wasn't that the name? The name is cluster wide privilege pods, which is the name of the policy. Oh, prefix. Yeah, so it's prefix. It's cluster wide. It's a prefix dash privilege pods. And then it's listening. So this is an HTTPS endpoint. So that's the secure transfer. But the API server needs the CA, right, to validate it. So the kube controller did that work in there. And then the filter of the rules is here. So it's only applicable to pods. This is exactly the information that was in the policy. And it's going to be sent to that endpoint on the policy server. And then the WebAssembly will run and it will say A or nay. So let's give it a try. Any comments on the chat? Let's see. We have even compiled the kernel code base into WebAssembly and ship it in experiment Kubewarden policy. Oh, okay. So the one of the maintainers is saying that if you want to take your existing kernel policies and run them in this sandbox in the policy server, they already have compiled the kernel logic into WebAssembly to be running that sandbox. So I think this is what I did. All this, I explained this live. I didn't went by one. Like I explained this. The webhook is running. That's what I showed. And then if I try to create a pod that is normal, not asking for privilege, it should work. I think this example should be the opposite. It should show me like not working and not working. But tomato, 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 tomato. So I'm going to create a pod, and the pod got created. It was happy and it's running. If I create one with privilege, right? Security context privilege, and then if you don't know what privilege is, it's a very bad thing. And it basically the pod will have more access than it should to the host operating system in Kubernetes. So if we run this, I should get an error. Let's see if we get an error. If I don't get an error, then I did something wrong. And I got an error. Cluster admission denied. And that happened. So the idea is like if I have 100 of these denied requests and I want to collect that, how do I know that that happened? That somebody tried that. So that's where, well, you can see the logs. So that's one thing. Kubewarden. So policy server, deploy. Why? Let me say get deploy. I want to see the sure. No, this thing is whack. So I want to see this log. So if you have like logs stream for auditing purposes, then that would be your audit. One way of doing audit, right, through logs. Hopefully they're, I think logs were set to info. So I don't know if that would show here. There we go. They're in JSON format, which is a good thing. So we got the error here. I think it's info. Yeah, it finished with 200. So everything was fine. It replied, but I don't know if we'll capture the error. It says it's starting to validate. It says create. So I don't think so. That's capture. So the maintainers can answer that. Maybe have to increase the log level to actually see if it was not allowed. So this is the starting to evaluate it, right? And then this one saying that it finished processing. But I want to see like what it responded with, if it was responding with allowed or denied. So maybe that's the next level of the logs.
But 7-minute warning.
Cool. Okay, I think almost done. I want to show the audits. So for the audits, I think that was the getting started for this. Get validation, get mutation. I did this. I think it was the audits I wanted to show. Audit scanner. So audit scanner, which is the thing that I was looking for, was this is optional. So I think this is what I did. The policy report. The cron job is there to create the policy reports. So the way I can trigger that job. Let me see if I can trigger the job here. You can trigger the job after that failure, or after. Yeah, let's see. Maybe yeah. So the thing is with the audit, it needs to be something in the cluster. We'll find something that is the cluster that is not following the rule. So I would need to have like a privileged pod already created, and then created, and then the scanner will like try all the policies and create reports. That's how it's going to work. But I don't know if I can to get the time to. They say yes, debug full response. You have to run in debug mode, debug log level. So let me see if I can try to do this quickly. Policy to show the scanner. Well, let me show the policy. It will not show anything because what I said. Like, but if you put this policy on an existing cluster that already has paused in privilege, it will start creating reports, and then you will see the policy report. So let me get the service Kubewarden so I can show it. So it's this UI, right? So it's listening on 8080. So if I do get port forward, and this, no, it's not listening on port 80, listening on port 8080. Oh, it's not the policy server that I want to listen. I want to listen to the policy report dash UI. And I'm making a reporter. I didn't use autocomplete. There you go. So if I open it, I think it looks like the same that kernel policy reporter uses. Let me see, localhost 8080. So it's empty because It's empty because there's no reports, because this thing have not running. So I can trigger it. Let me see if I can trigger it. Where was that thing? Let me trigger the job. So I don't think the job have run. If I do get jobs, Kubewarden, yeah, it's not running. So as you saw, there's no reports because so this scanner, what it's going to do is it will find all the policies, and then it will take all the resources that I find with the rules and combine those two things, and then try to send it to the policy server and get, if it failed or not, get the results, and then take all that information and create a policy report, CR, and then the policy reporter will be able to gather those reports, and then the UI basically is a web app that you will see it. So let's see if this is done. So it's complete. If I go report policy reports, I think it's policy report. There you go. So there's two. Let me see if now it shows something in the UI. There you go. So colors. Everybody likes colors in DevOps. So somebody asking if this project provided. No, it's not provided by AWS. I'm just a CNCF ambassador showing this project. But you can run an AWS on EKS. Not trying to sell anything. But yeah, I think this is the same policy reporter UI and project that also compatible with Kubernetes. Maybe the maintainers can correct me or not. It looks very similar. I'm more familiar with Kubernetes than anything. But here is the policy, right? It found the policy and it found local path provision. This is another policy. Interesting. No, this is the cluster wide, and it's passing. So it looks like I have one pod. It did it, so it is passing. If it's failing, then we'll say that it failed. If there's errors, like for example, the WebAssembly code has a bug or something like that, or crashes, then I'm guessing it would be captured as an error, like it returned with an error, like not 200. Warn is, I think it's, I don't know what's the difference between warn and failed, but I think we're almost out of time. Let's see if there's more questions. Jose Guilherme says that it's the same UI as policy reported. So policy reported, I don't know if there's a link to the project. So it's like you create them. That means they create a kind of a standard, right? Schemas for any Kubernetes project or non-Kubernetes project to create this type of policies. And gather them. Let me see, Kubernetes. Yeah, I think it's this one, policy reporter. So yeah, it's the same thing. I remember that I saw this UI somewhere else, but yeah, neat that it's compatible. So Kubewarden didn't have to like create a new way of like reporting policy violations and things like that. And policy reporter is already compatible with other. Where are the docs for this thing? Yeah, I was going to say this policy reporter thing is compatible with many other endpoints. Like it can send this information to, for example, Grafana, or it can send it to cloud providers, security incidents type of things. I'm familiar with the one with AWS configuration, Security Hub, but other than that, yeah,
Sorry.
they leverage that.
Sorry, we got to cut it off. Sorry, and we are at time. Thanks, Carlos. Appreciate it, everyone, and we will see everyone next week. Carlos, when can we see you next?
I don't know where I'm in the schedule, but we'll let
No,
everyone
I meant
know.
everywhere. Are you in London?
I'll be in London. I have two talks in London. I have one in the main track it's called how GPUs work in Kubernetes. Tell me how Kubernetes work how GPUs work in Kubernetes like I'm 5 years old.
Yeah. Yeah.
Yep, I'll be
Yep.
in London